What happened here?
No, screen is not showing you. We are seeing you. I mean, did you share your presentation or something?
Yeah, let's see.
Let's do it again.
What happened here? Let's go back to Zoom.
Dr. Ashwardhan, good evening.
Oh, there it is. Is that it?
Yes, that's it. It's on the
Okay,
screen.
good. Yeah. For some reason, it popped off.
Yeah. So now you can stop your share and take it on when it's required. So, Watson, you can stop the share right now.
Stop the share? Okay.
Yes.
Stop share. Yeah, there we go. Okay.
Because
Great.
there will be some initial formalities.
Right, yeah.
So we have academicians also with us. Here we have Professor Jyoti Busari. He is the head of the Department of Civil Engineering in a college in Western India.
Hello,
Great.
Hello.
Hello.
Vinayji, we are past 1 minute past 6 o'clock. Should we begin?
I leave it to the coordinator, Mrs. Ruhi.
He is gone silent. He's on mute for some reason. And
So she's broadcasting the event.
okay, all right.
Yeah, can I do the broadcast?
Yes, Rohit.
Yes, please do.
Yeah, done.
So should we make a gradual start, you think?
Vinayji, I
Gobe
think
sir?
yes, I think we should begin.
Okay.
Let's wait. I would suggest wait for few minutes.
Okay, 5 minutes, fine.
Maximum 2-3 minutes. Yeah.
Yeah. So should we make a gradual start, you think?
Vinayji, I
Gobe
think
sir?
yes, I think we should begin.
Okay.
Let's wait. I would suggest wait for few minutes.
Okay, 5 minutes, fine.
Maximum 2-3 minutes. Yeah.
Yeah. So should we make a gradual start, you think?
Vinayji, I
Gobe
think
sir?
yes, I think we should begin.
What is this? My sound got recorded. It seems as playing again and again.
Few minutes.
Okay, 5 minutes, fine.
Maximum
Rohit.
2-3 minutes. Yeah.
Yeah. So should we make a gradual start, you think?
Hello, Rohit.
Gobe sir?
There's a
What is this? My sound got recorded. It seems as playing again and again.
few minutes.
Okay, 5 minutes, fine.
Maximum
Rohit.
2-3 minutes. Yeah.
Right.
Namaste, sir.
Dr. Gopal Rai, namaste.
Hey, Gopal.
Good to see you.
Yeah, good evening, all. Harsha Subbarao here. Good evening.
Good
all.
evening, Dr. Subbarao. We have heard a lot about you, but
Ranjan. Yeah.
yeah.
I think Dr. Harshavardhan and on the other end, Mr. Atul Bhobe, they're all quite into bridges. And especially I know Mr. Atul Bhave's company, they're dealing into a lot of cable supported bridges of various kinds, including arch bridges.
Wow.
And I think whatever I know, this Worli Bandra, the first major cable stayed bridge of Mumbai,
Yeah.
has used.
Don, where are you broadcasting from at the moment?
We're located in Western New York, in Buffalo, New York.
I know, but where are you at the moment?
Oh, I'm at my office. I'm at my office.
In Buffalo?
Yeah.
Okay, okay. We have met quite a few times at IABSC and FIB events.
All right. Okay.
I
Yeah.
recall. Yeah.
Yeah, I do recall. Yes. Good to see you again.
Good to see you.
So I think it's better to start because people know that our actual lecture begins later, so they join also later.
Okay.
And we can't help it. So I think
Silence
it's better to
everyone.
start
Mute everyone.
because people know that our actual lecture begins later, so they join also later. Once again, the recording is coming, and we can't help it. So I think it's better to start.
Yeah, we can. Please go on.
Okay. Okay to start then?
Yes, please.
Okay. Well, thank you very much. I appreciate the opportunity to talk to you today from Buffalo, New York, where it's early morning. And I also appreciate you staying to hear me on the evening, Friday evening. So it's a great thing. A little bit I think as far as background, we got upper bearing plate, and then you have a mirror finished stainless steel top plate that goes on top. So now you have a bearing that can move in any direction and also rotate in any direction. Now, dimpling is sometimes used. We'll use dimples and grease in there to reduce the friction even further. But not everybody uses dimpled and lubricated Teflon. It's kind of, in the USA, it's kind of a mixed bag. So here's a bridge that had some multi-rotational bearing. It's a bridge in Pennsylvania. Very tight working space so that they're working in there. So here you can see some of the disc bearings supporting those plate girders at LaGuardia Airport. This is a project in Ohio. It's called the Valley View Bridge. It's kind of an interesting project in that it's the most heavily traveled bridge in Ohio. They get 180,000 vehicles a day. Again, the existing bridge is about 40 years old, actually in pretty good shape, but it's overworked, too many cars. So this is what it looks like in rush hour. Again, you can see it's backed up both eastbound and westbound. So what they're going to do is they're going to build a bridge in the middle, a new bridge. Then once the new bridge is completed, then they'll switch traffic over to the new bridge and retrofit the older structures. It's kind of an interesting project. So they use this erection gantry here to drop the girders in between the two existing bridges. That's the gantry. And there you can see them dropping girders down on the new pier. So 133 disc bearings were used on this. The vertical loads were pretty standard, nothing too outrageous there, maybe getting up to 3,000 kilonewtons, somewhere in that range. Horizontal loads, some of them are quite high, up to 40%. Rotations are pretty standard. Movements, nothing out of line there. Here you can see some of the masonry plates in the shop. We're welding the lower bearing plates to those masonry plates, painting the components, and then fully assembled in the shop. So here the bearing is shipped to the site. It's a field weld connecting the upper bearing plate to the girder. Now it's very important, especially with field welding, that you don't generate too much heat on the plates adjacent to the polyurethane and also the PTFE. So they have these wax crayons they put on there that measures the heat. So you want to make sure you don't overheat the critical components. So there's one of the finished installations of the bearings. We typically put on a plate, information plate on each bearing. It's got the company name, date of manufacture, name of the bridge, location. So all the critical information are on these plates. So if you come back 10 years later doing an inspection, you can see all the critical information. So there's the finished new bridge in the middle, and then now they're going to do the retrofit on the exterior bridges. So kind of an interesting project. Another interesting project, this is a Delta frame design. This is in West Virginia over the Shenandoah River. So the bearings are actually down here. They're actually quite inspectable. And there you can see the disc bearings that were supplied for that project. And again, they're set up on shims in this case, which are nuts. And then they'll grout that into place. And then their bearings are fully assembled. So for inspection, it's actually quite easy. You just probably take a ladder, get up and look at the bearings during your biennial inspections. Steel boxes use a lot of disc bearings. Here's a steel box bridge in Orlando, Florida. And there you can see a couple of the disc bearings supporting those steel boxes. There's another steel box application. This is what they call a diverging diamond interchange. This is the latest thinking on keeping traffic flow going from divided highways, exit and on ramps. They use these, what they call diverging diamonds. They're quite popular now. So these are steel boxes too. So it's kind of interesting here when you look at this box supported by two bearings, this box supported by two bearings. This one only has one. So again, the engineering behind that is something that was carefully worked out, but they determined only one bearing was needed for the interior box. Steel arches. This is a bridge in Portland, Oregon, the Selwood Bridge that utilized disc bearings. A little shout out to the iron workers who built this bridge. So there's one of the bearings at the abutments, one of the disc bearings. You can see the load element. Looks like it might be a slide bearing as well too. Also bearings on top of the spandrel columns there. But then also this bridge had bearings between the edge of the arch rib and the shear blocks. So these are lateral bearings. And I know we're talking about using some of those on a project in India as well too. So there you can see a disc bearing that's used in the lateral direction. Interesting with this type of bearing, the load may not be on it full time. You know, it's a design where maybe it's only loaded during wind or seismic conditions. But one of the nice features of the disc bearing is it can accommodate rotations at low or even zero load. There's no minimum load required for that bearing to accommodate rotation. This is a bridge in Arkansas, the Broadway Bridge, that sits on disc bearings. But there's also another interesting application of disc bearings on this bridge. So these are the temporary struts that hold up the arch rib. And the base of that temporary strut has a little disc bearing to accommodate the rotations during the erection of the arch rib. So there you can see they painted it white, so you can't really see the red disc there, but it's right there. But just another interesting application for disc bearings. This is just kind of a cool picture. It's the Rio Grande River Gorge Bridge in New Mexico, and they retrofitted the old roller bearings a few years ago with disc bearings. We also worked on the Hoover Dam project. This isn't not too far from Las Vegas. 24 disc bearings on this. This is a North American record for a concrete arch. I think it's around 320 meters span. So the bearings are on top of the columns supporting the deck. Now these tall columns, some of them were like 100 meters tall. Those were integral. But the shorter columns have bearings underneath, also bearings at the abutment. That's actually the rendering of the bridge. The renderings are so good now, it's hard to tell them from the real structures. So here you can see one of the bearings for the Hoover Dam project. Most of the specifications we deal with today require that the bearing have a replaceability scheme being designed into it. And should something ever go wrong, you can get at it and remove it. So in this case, you have a cast-in upper plate, but the upper bearing plate is bolted into that. There you can see the bolts. Similarly, the masonry plate was grouted in, but the lower bearing plate is bolted into that. So to facilitate removal, you would jack the structure, draw those bolts out, and you can actually pull the bearing out in one piece. So that's about 300 meters over the river, which is normally a little higher than I normally like to go when I'm looking at bearings. A lot of these bearings are big bearings, but they're also slide bearings, so they can actually move around on you during installation, and that's not what you want to happen. So in many cases, we'll put some external angles on like this, which essentially holds the plates together. They're slotted, so you can adjust it for temperature setting. So once the final connections are made, then you would take that hardware off. So that's the real bridge once it was completed. So it's kind of an interesting structure. It's certainly a famous site with the Hoover Dam in the background. But if you ever go to Las Vegas, that's a good bridge to take a look at. Cable Stay Bridge over the Willamette River in Portland, Oregon. That sits on disc bearings. Here you can see one of the disc bearings for that. So this is a good picture just to emphasize a point. People often ask me, how long do these bearings last? And really, they should last the life of the structure. But what we see in the field many times is deck drainage pouring down on the bearings. And oftentimes that deck drainage, especially up in the northern states, has de-icing salts in it, which corrodes the plates. So long term, I'm not worried about the polyurethane pad, but it's the plates that can start to prematurely corrode. Now, in this case, they had not installed the joint yet, so that's why it was leaking like that. So once the joint was installed, that stopped. But in many cases, you go out and look at older bridges, you see deck drainage pouring down on the bearings. So that's something you need to deal with. A lot of pedestrian bridges use disc bearings. This is an interesting pedestrian bridge in Ohio, Cable Stay Bridge, and had our disc bearings also designed for uplift, which I'll talk about in a minute. This is a pedestrian bridge in Chicago, also had some uplift bearings. This is actually a bridge built for horses to cross the LA River in Los Angeles. It's an equestrian bridge. I haven't done too many of those. And then also another pedestrian bridge in Dallas. But pedestrian bridges are quite interesting. So this is a new bridge in Minneapolis to replace the one that collapsed, the I-35W bridge. 54 disc bearings on this concrete segmental bridge. It looks integral there, but there's actually a gap right here where the disc bearings are located. Some of the bearings on that were designed for 25,000 kilonewtons capacity. So that's a disc for a 25,000 kilonewton load. That's the main pier where the big bearings were located. And then again, here you can see that replaceability detail, bolted, accessible connections, allowing the bearing to be removed. I often consider that a new bridge, but it's actually over about 13 years old now. So this was a retrofit we did. This is I-75 in Saginaw, Michigan. And the original bearings were pop bearings, but they had problems with sealing ring failures on the pop bearings on this bridge. So we got the contract a few years ago to replace. It's like 135 bearings that had to be replaced. Now, some of those bearings were on the order of 35,000 kilonewton capacity. So there you can see quite a big disc bearing for that. Now, these yellow things, you're probably wondering what those are. Those are the temporary hold downs that holds the plates together. So again, once the final connections are made, then you take those off. So the reason we paint them bright yellow is a reminder to do that. I remember I was out on a bridge once several years after the installation, and the temporary hold downs were still on it. So we paint them bright yellow now as a reminder. So there you can see one of the bearings for that bridge in Michigan. So this is an extra dose bridge. I know you have some extra dose bridges in India's, but it's a cable supported bridge, but instead of the big tall towers, you have the short squat towers. So that's a cost effective design for certain span lengths, but it's a big, heavy concrete bridge. So some of the bearings at the main pier were designed for 45,000 kilonewton load. So 45,000 kilonewton load is about 1.5 meters diameter disc, maybe 200 millimeters thick. So that's a big disc. Fully assembled, each bearing weighed 21 tons. So there's a picture of me laying on top of the bearing so you can see how big that bearing is. And then here's a shot of us doing the installation. So I was hoping all those anchor bolts lined up with those holes, which they actually did in that case. So of course they wanted these bearings tested. So we had to go to it was beyond our capacity. So we had to go to the facility at University of California at San Diego, where they have a big test frame there. So they can go up to maybe 60,000 kilonewtons vertical load on this machine. They have vertical actuators, horizontal actuators. They can do seismic testing. We actually tested some of our seismic isolation bearings on this facility as well, too. So if you ever get to San Diego, that's a worthwhile stop. So here we are doing the testing on that big bridge in Connecticut. So our testing capabilities are quite good. We can go maybe up to about 40,000 kilonewtons vertical load on our big test frame. We have a horizontal actuator to do friction testing, also horizontal load testing. So we keep this machine pretty busy. We have a large displacement actuator. This can maybe do plus or minus 650 millimeters of displacement. So if you're looking for some large displacement testing, we have that capability. Here's our large displacement test frame. You can see how that would operate. And then a smaller test frame. This maybe goes up to on the order of maybe 15,000 kilonewtons, somewhere in that range. Smaller bearings are tested on this as well too. But we have extensive testing capabilities. We test other people's bearings. We test, bearings for different industries as well too. So if you're looking for some high capacity testing, we have that capability as well too. Uplift is something we see pop up quite a bit nowadays. Uplift is common in seismic zones because earthquakes don't just go back and forth, they go up and down as well. Sometimes on a curved girder, you might see an uplift reaction during certain conditions. But one of the ones that pops up quite a bit now is flood-prone regions, and we saw that during some of our hurricanes in the south where sections of highways floated away. You don't think of bridges being buoyant, but they can be. So that's another application for uplift. We modify the SRM or central pin, kind of make it like almost like a trailer hitch on your automobile. It allows rotation, but keeps the plates from pulling apart. So we connect the upper and lower bearing plate through that. Then if you want movement, the guide bar would then lip underneath the upper bearing plate. So fully assembled, this bearing looks like this. So it can move and rotate and resist uplift. We do a lot of bridges, but actually buildings use uplift disc bearings as well too. This is the AREMA up in Calgary, Canada. It's a hyperbolic paraboloid ring beam supported by uplift disc bearings. So there you can see the uplift disc bearings holding the roof of that structure. Another application for uplift, this is the Penobscot Narrows cable stay bridge up in Maine in the northeastern part of the U.S. It's kind of interesting. They have an observation deck in the tower, so you can actually take an elevator up to the top and look out over the countryside. Nice idea. There's one of the uplift bearings for the bridge up in Maine. This is a project in Seattle. This is part of their light rail system. We do a lot of light rail structures as well too. This is called Sound Transit near the airport, precast segmental design. Here you can see the uplift bearings for that project. Here's another area where there were fixed uplift bearings, also using lockup devices or shock transmission units, sometimes they're referred to. So used in conjunction with the disc bearings. Another project in New York City, this is a case where they were replacing old girders nights and weekends to keep the trains running during rush hour. There's a little hinge detail here. The problem is we had a very limited height to work with. So instead of the conventional guide bar underneath the upper bearing plate, we used a wedge plate detail like that. So that enabled us to achieve uplift in a much lower profile. So we do a lot of specialty designs like this. So if you have an application and you want to look at something unusual or different, we offer that service to engineers. Another project that have uplift bearings, this is the new Kosciuszko Bridge in New York City. And that had some of our uplift bearings. Here you can see the uplift pins on the plates there. The discs haven't been installed yet. And there you can see installed what it looks like in the field. Of course, we've done a lot of international projects, especially some in India as well too. This is the Bandra-Worli Sea Link Bridge in Mumbai. And disc bearings were used on that project. There's a picture of the bearing with the protective coating on it in the shop, in Metco's shop. There's a picture, you can see the big concrete segment being supported by disc bearings on that. So that was a fun project to work on. Also, the second Vivekananda Bridge. This is an extra dose bridge. Again, we talked about that a little earlier. Again, cable supported with short towers. So that had disc bearings on it. And Atish was kind enough to send me this picture. He reported that they've done a recent inspections and the disc bearings are performing well. This is another project. This is up in Canada. This is the Port Mann Bridge, cable stay bridge in Vancouver, BC, Canada. And there you can see one of the disc bearings for that. Now, in addition to the vertical bearings, we also had some lateral bearings on this one. This is between the deck and the tower. There you can see the lateral bearing. Again, like that bridge in Oregon, it's only temporarily loaded at times, maybe during wind or seismic. So again, disc bearings work good in that configuration. A lot of retrofits too. This is the Manhattan Bridge in New York City, over 100 years old. Here you can see the old rocker bearing nest, as they call it, because you're putting rockers together. You can see where the bolt sheared off of the last rocker, so it's fallen apart. So we got the contract to replace those with disc bearings. Here you can see the disc bearing design that we came up with. So it's interesting, is a common masonry plate for two separate discs. So that was what we engineered to replace those old rocker bearings. There's another bridge in New York City, Cable Stay Bridge. Gothel's Bridge is the name of this one. Here you can see the bearings in the shop with the beveled upper plate to accommodate the grade of the structure. And there you can see them installed. Stainless steel hardware, that's common now, because a lot of times those bolted connections could rust. So with stainless steel, you're providing something that'll last a little bit longer. This is in the Outer Banks of North Carolina, the Bass Knight Bridge segmental design. Here you can see the disc bearings. Again, those are the temporary hold downs that we paint bright yellow as a reminder to remove them later on. Kind of a nice picture. Sunrise over the bay there, over the segmental project. Another segmental project in Virginia Beach, Virginia, that utilized disc bearings. Here you can see some of the disc bearings sitting on the pier waiting for the segments to be dropped on top of them. We also do some specialty high rotation bearings. This is kind of a design we came up with several years ago. It's designed for extreme rotations, up to 8% rotation. We utilize this design for. It's not unlike a pot bearing. You have a cavity here, you drop the disc in, and then you load it. You don't have to put sealing rings in there because you're not overstressing the elastomer. But we're using the outer wall of that pot there to accommodate high rotation, also high horizontal forces. Sometimes we use these for. So that's our POD pod bearing that we designed for that application. Bridge that utilize these is this bridge. That's that Cable Stay Bridge in Dallas, Texas. It's a Calatrava design. He's a famous architect over the Trinity River. And there you can see the requirements for high rotation. The bevel goes lateral in this way, and you can see why, because the load beam, as you can see, is beveled as well. So that was the reason for the bevel going lateral on that project. There you can see the loaded bearing. Just kind of a cool project. This is up in Vermont, I-91 in Brattleboro. Precast segmental design, but little fancy work on the substructure piers. Kind of a nice way to jazz up a bridge. There you can see one of the bearings for the Brattleboro project. So I got an order once for one disc bearing. I'm thinking, well, what kind of a structure is that? And it was actually this structure. It's a BMW dealership out in Portland. And the central column supporting that tent splays into 3 columns halfway up. So there's actually one disc bearing supporting the central part of that column. So it splays, as you can see. So behind all that emergency lighting, you can see that. So I thought I'd get a discount on a BMW, but the guy said, no, that doesn't apply. So I still drive a Jeep. So curved girders create problems for engineers, especially with guide bar alignment. If you go by the rule book, you go from your fixed point to your expansion point, and you draw a chord. But I mean, who's to say that's the way the bridge really wants to move? So curved girders create a lot of problems for that. One of my favorite curved girder bridges is this one. This is actually a ramp to a suspension bridge in Japan. But can you imagine trying to line guide bars on something like that? But guide bar alignment is an issue. I've seen guide bars shear off. This one looks like it's about to shear off, as you can see there. So where there's uncertainty about direction of motion, what we can do is put some of the polyurethane pad on the guide bar, so it's on both sides. So what that gives you is a tight fitting bearing, but it gives you some lateral play in either direction. That's what we call flexible guiding. So here you can see a flexible guided bearing. Also has uplift restraint designed into it as well. This is a project in West Virginia that utilized some of our flexible guided bearings. You can see the approach to this bridge on the one side has a sharp curve So they opted to use flexible guided bearings at the expansion piers. So here you can see we colored the polyurethane a little different color since it's a different material, slightly different material than the actual load element. We do a lot of light rail projects, as I mentioned before. This is the metro project we did in DC, Washington, DC. It's called the Silver Line. It goes out to Dulles Airport, which is on the western side of Washington, DC. Again, precast segmental design. Now, they had issues with elastomeric bearings and also pot bearings on previous metro projects, so they decided they wanted to use disc bearings on this segment here. So it's elevated in many portions of the line that runs. It's 20 some miles. And there you can see some of the disc bearings supporting those segments. So they're not really big bearings, but I think we totaled about 2,000 bearings for that particular project. Here's another light rail project. This is down in San Diego, California. Steel plate girders. Again, here's another replaceability detail. The disc is sitting in a recessed plate. And then there's an extra sole plate, which is welded to the girder. So for removal of bearing, you draw those bolts out. You'd have to jack it up a little bit, and you can pull it out. Class 1 are the heavy rails. They use a lot of disc bearings. Here you can see there's a bridge in North Carolina that's sitting on our disc bearings. Now, for railroad structures, there's a different specification. For highway bridges, we use AASHTO. For rail bridges, we use AREMA, but AREMA has a disc bearing specification in it. And again, for the heavy rails, they don't allow pot bearings. This is a bridge over the Ohio River that we worked with Norfolk Southern Railroad. Now, the central span is actually designed to be a swing span. This bridge was over 100 years old, and I think they swung it open once or twice after they built it, but never did. So they decided to replace the beveled swing bearings. So the way that works is you'd pull that plate out, and then it would allow the structure to rotate. But again, they hadn't done it in so long, they decided to replace them with permanent bearings. So there's the disc bearing that was installed in place of that wedge plate bearing. Working on this project now, this is a rendering of the new Merchants Bridge over the Mississippi River in St. Louis. That's a heavy rail bridge. Some of the bearings on that are going to be designed for like 30,000 kilonewtons. So those are some big discs as well too. There you can see the discs in our shop right now. Other active projects, this is the People Mover, rendering of the People Mover at Los Angeles, LAX Airport. And we're doing the bearings for that. Again, because it's California, the forces are quite high, especially the horizontal forces. Here we are doing some horizontal load testing. The jacks are applying the load here. This is your reaction plate. So when we did the horizontal load testing, they sent 8 engineers out to witness the testing. This was just before the COVID hit in early 2020. So they had a bunch of engineers come out to witness the testing. Here you can see one of the bearings installed at the LAX Airport project. Another project we're working on that's active right now is the high-speed rail. They're actually building a high-speed rail from Los Angeles to San Francisco. Right now they're working on the Central Valley part, which is Bakersfield to Fresno. So here you can see a picture of the high-speed rail being built. So there's a lot of bridges on this high-speed rail. And again, California design codes, so high forces. Here you can see some of the bearings in our shop with big SRM pins for that application in California. Another project in Washington, D.C. This is a rendering of the Frederick Douglass Bridge. This bridge has some very large displacement bearings. You can see the slide plate on that. There's some construction photos. So that project's moving along. That was from the summer. This is the new Ganga River Bridge located near Sultan Gaj, I think it's pronounced Sultan Gaj. And that's going to have disc bearings on it too, being manufactured by Metco. And Atish sent me this photo here. So this is an interesting design. It's a design for service uplift. So for service uplift, what we do is we have a double disc. So you can't actually see the one below, but there's a disc on top of the lower bearing plate, and there's a disc underneath the lower bearing plate. So for whether the bridge is in uplift or in regular vertical load, there's a polyurethane pad to accommodate the loads and rotation. So that's quite a bearing that was manufactured for that project. So this is a project we did in Texas several years ago. It's Fort Worth area. And they had these arch segments that were dropped down on the bearing. So during one of the installations where they're dropping the segment down on the bearing, they had an accident where the crane tipped over or something like that happened. So what ended up happening to the bearing is all the load was on one edge of the disc. You can see, it's hard to see that photo there, but the entire load of the structure was on one edge of the disc. So obviously that disc was overloaded in that particular instance. So the contractor called and said, hey, I think we're going to have to replace some of these bearings. I said, well, you know, jack it back and take a look and we'll see what happens. So when they jacked the structure back, no damage at all to the disc. So that's an example of an overload application where there was absolutely no damage to the disc. And that's common, especially during girder erection, that you'll get overloads and over rotations. Again, the polyurethane pad has tremendous capabilities for that. This was a project up in Canada. We installed some bearings back in the 80s. Several years later, they upped their seismic criteria. So all of a sudden, the old bearings don't meet the new spec. There was nothing wrong with the bearings, but they decided to replace them to get them up to spec. So I said to the contractor, I said, you know, give me some of those discs because they were in service for 32 years. So we got the discs, pulled them out, and they looked fine. There wasn't a mark on them. You know, they were really in excellent condition. So what we did is we took one of the discs, we cut up some tensile strips and compression buttons, and then we ran the physical property testing on the 32-year-old material. So on the left column here, you can see is a compilation of tests that we ran on brand new discs. And on the right is a compilation of tests that we ran on the 32-year-old material. So a little bit of a degradation in tensile strength. Elongation was about the same, a little bit higher compression strength. But the column on the right still meets the specifications. So I could take those 32-year-old discs and supply them for a new project, and they wouldn't be able to say no. Not that we would do that, but kind of gives you a good feel for the long-term performance of that polyurethane load element. But the best example of performance is older applications. This is the project we did back in around 1990. It's the Windward Viaduct in Hawaii on the island of Oahu on the north side. Kind of a cool picture of that. So these bearings are about 30 years old. A little bit of plate corrosion. Our recommendation to the owner was due to do some remedial painting, but 30 years in a very corrosive environment with the ocean right there, performing quite well. This is a project up in Denver, I-25, I-70 interchange. These bearings were installed in the mid-'80s. Again, keep the drainage off the bearings. They'll last a long time. And then this is a project in Washington State. It's the Pasco-Kennewick Bridge over the Columbia River. So the span is about 900 meter, I'm sorry, it's about 300 meter main span. The bridge is about 900 meters long, and the deck is continuous. So they had one expansion joint on that bridge at the one end. It was designed for about 650 millimeters. And there you can see the bearing at the expansion joint, which was also designed for 600 millimeters of expansion. So that's done quite simply with a sliding bearing, though, by just increasing that upper slide plate. So that's a picture taken of that bearing probably around the time of installation, which was 1976. And I was out there a few years ago and took some pictures of the bearing. So this is 40 years later. So you can see still in excellent condition. The sliding is still working good. The disc is in good shape. Some cobwebs, things like that. You can actually see how much it moves. There's like a streak mark on the stainless steel. It's almost like a movement gauge. It doesn't move that full 650 millimeters, but moves quite a bit. The other thing we're active in is the earthquake market. One of the ways of dealing with seismic forces is to isolate the structure. Seismic isolation is quite popular in many regions. U.S., there's actually quite a few seismic zones, not just West Coast. But one of the more popular seismic isolation bearings is the lead rubber bearing. So you have conventional elastomeric bearing, and then you have a lead core. So the lead core, as it cycles, shears and dissipates the energy. But some of the concerns with lead core bearings is what happens after an event. So I was over at the Earthquake Center at University of Buffalo, and they did some routine testing on lead bearings, lead rubber bearings. Then they cut them open after the testing. So that's what it looks like after testing. So again, not a solid piece of lead anymore, some internal damage to the plates. So again, there's some concern you may have to replace these after an event. So with that in mind, the disc bearing can be modified for isolation as well too. Thicken up the upper bearing plate, outfit the perimeter with springs. The springs are actually made out of a polyurethane as well too. So polyurethanes are used for springs in a lot of industrial applications. So what you have is a multi-directional bearing with a built-in restoring force through the use of these springs. The damping or energy dissipation comes from the sliding material. So Teflon at thermal speeds is around 2% mated up against stainless steel. But if you speed it up, the friction goes up with velocity. So that kind of works with you. So the higher the friction, the more damping you get. So this is a spring. This is the housing we use to connect it to the upper bearing plate. It's got sliding material on the back side. This is a test that we ran. These are two springs sandwiched together. There's a plate separating the two springs, and then there's a rod running down the middle. So this is compression testing we ran on the springs. Now, when you look at the sample of that spring, it doesn't look like it would have that capability. But as long as you stay in the elastic range of the material, you can do that all day long. There's no real fatigue or stress on the components. So not only would it have to compress, but it would also have to slide at the same time. So this is representative of the type of reaction it might see during a seismic event: compression, relaxation, sliding, all at the same time. So we're fortunate actually where we're located, not too far from the Earthquake Center at University of Buffalo. So they have seismic simulators and shake tables and all sorts of fun equipment that you can test your concept on. So many years ago, we tested this concept out. These are the bearings at the corners, plate girder bridge. Those are lead bricks to simulate the dead load. And then we cycled the bearings through 50 different earthquakes. We got good force reductions, manageable displacements, and it came back to within a couple millimeters of its original position in all the testing that we ran. So good restoration force capability as well too. So after the 50 earthquakes, we just flipped the machine on and shook it for a while. I apologize for the quality of this video, but it was taken many years ago. So those are the yellow springs that are shoving that bridge back and forth. This is more like a durability test. We're just shaking the table and testing the bearings. So after 50 earthquakes and then the durability test, the bearings were still functional. You can see the springs are kind of small. It was scaled down for that application. So after 50 earthquakes, the bearings still work. And that's important because earthquakes don't come as one event. There's precursors, there's aftershocks. They have to work over and over again. So this is our test frame we built and donated to the University of Buffalo. So this is where we do our high-speed or dynamic testing. We have a working relationship with them where if we need to do some testing, we can just go over and do it. So lots of different projects. You know, as I mentioned earlier, we always think of California when we think of earthquakes. But I think it's like 39 out of 50 states have seismic issues. So New York City, there's, you know, historical data that suggests there's been major earthquakes in the New York City area. So that's obviously an area of concern as well too. So this is JFK Airport, Terminal 4. This is the International Arrivals Building. So if you fly from Mumbai or Delhi to New York City, you'll come in at Terminal 4. And this is the ramps leading in and out of the terminal. So we use isolation bearings here. Here you can see the spring design on this one. That fits over the disc on top. So fully assembled, that's what they look like and installed. So it's a plate girder bridge, as you can see there. And that's the box. The disc is here, and those are the springs. So you can actually do a post-earthquake inspection of these bearings quite easily as well, too. This is the airport at Buffalo, where I live. Now, this engineer said, well, we got round columns. I want a round bearing. So we made the upper bearing plate octagonal. We had 8 springs going around the perimeter. So when they're installed, they look like that. So it's really the same as that rectangular one, but in this case, we used an octagonal upper block. This is a project on the California border. This is a high seismic zone, Arizona project. It's in Yuma. Now, this isn't a fancy bridge, but that's a lifeline structure. So that needs to be functional after the earthquake. So this has to carry emergency vehicles over the railroad tracks. So the existing bearings look like that. Now, you don't need to be a seismic expert, but look at that bearing, picture some ground motion. You might have a problem with that design. So what we did is we drilled new anchor bolt holes outside the existing masonry plate, jacked the structure up, burn out the old bearing, and then installed the new sliding isolation bearings on that. So there you can see the, again, they're stitching the welds there to keep the heat down. They eventually filled that in. But this project had 16 bearings, not big bearings. But the total retrofit cost, including jacking, removal, and installation of the new bearings, was $70,000. So not crazy money to seismically upgrade a lifeline structure. This is a project down in southern Illinois. Again, the same type of deal. The existing bearings look like that. We replaced them with sliding isolation bearing. So that project had 481 bearings. So that was a big project. There you can see the new isolator that we installed. Retrofit of a historic truss. This is in Seattle. The other thing we can do with this design is we can change the stiffness in different directions. So in this case, they wanted the bearing stiffer in the transverse direction. So these springs are actually shorter than those. So just by changing the geometry of the springs, we can alter the stiffness of them. So that's a common design feature where you have a stiffer design laterally. The springs are preloaded into the block. So this is our rig that we preload the springs. So it's got a 40-ton jack. Compress it down, and then you put these these are set screws that hold it into place. So once it's completely compressed, then you drop it into that box. Then you loosen the spring, the set screws on that. So that's how it's configured into that plate. This is a project in Ottawa, Ontario, that kind of a nice looking bridge that utilized our sliding isolation bearings. Also, they had uplift restraints. So now you're adding a different feature to the isolators. You want to resist uplift forces as well. But that can be done with this type of design. My favorite project we did is, of course, in Kolkata. This is the Atmosphere Condominium project, and it's a sky bridge connecting the two condo towers. And the sky bridge, if you look, is actually 3 or 4 stories thick. There's a health club, nightclub, pool, trees, all on the sky bridge itself. So there's only 4 bearings, but they were massive. So here's a picture of one of the bearings. You can see it's quite large. It's one of our sliding isolation bearings. I thought it was kind of interesting how the workers put some religious artifacts on the bearings to bless them. That was kind of a neat idea. There they are, lifting it into place, dropping the bearing into position. So I think Atish sent me that picture recently. So it's I'm not sure if it's complete yet or not, but it's a pretty cool project. The condos were really pretty neat as well too. And then lastly, we did a project in Mexico around 2002. And I think it was like 6 months later, they had a big earthquake there. So I called the owner. I said, hey, is the bridge still all right? He said, oh, yeah, it worked fine. You know, so everything worked out well. So that's not after the earthquake. That's during construction, so you don't get the wrong idea. But these trusses were prefabbed and barged into place. They actually used the pier to lift them. So they lifted the trusses with the pier, and then they put these corbels underneath the trusses once was lifted into place. So again, this went through a fairly significant seismic event. It worked well. I think in reality, what we do to these things in the lab probably exceeds what they'll even see during a seismic event. But it's nice to know that they work during a real earthquake as well, too. So that concludes just a couple quick conclusions. The disc bearings are cost-effective method of accommodating translations and rotations on structures. The field inspections show that they'll provide long-term maintenance-free performance. My cautionary note is always deck drainage. Keep the deck drainage off the bearings. And then they can be easily modified for uplift, high horizontal force, isolation. We offer a no-cost or obligation design service. So if you have a project in mind, you want to take a look at these devices, we can put together some details for you to look at. One last thing too, we've had other manufacturers be critical of the disc bearing. They say, you know, the resistance to rotation is too high. It's higher than a spherical bearing, but still quite low, comparable to that of a pot bearing. We haven't had any issues with edge pressure on the PTFE or the sliding materials, which is another claim that other manufacturers made. Another claim is that you can't inspect the central SRM or pin and that it could corrode, but it's actually sealed in there pretty good. And we've taken bearings apart that have been in service for many years, and there was no real corrosion on that central pin. And in all my years of being in this business, over 40 years, I've never seen a failure of one of those central pins on a disc bearing. So it's a good design there. Lastly, I've heard other manufacturers say the disc bearings aren't allowed in Europe. Well, that's not really true. There are just no disc bearing manufacturers in Europe. So nobody's promoting it. As a result, they don't have a spec for disc bearings in the European codes. So those are a couple myths I'd like to dispel as well too. So we also have a marketing alliance with a company called BDI. If you're looking to monitor a bearing to get the actual loads, movements, and rotation, we can equip the bearings with monitoring capabilities. We've got a project right now in India we're working on. And we also manufacture some joint sealing systems as well. So thank you very much. I appreciate the opportunity to talk to you today. I'll just put up my email address. If anybody has any additional questions that don't get answered, I'd be glad to address those.
So Ron, thank you very much for your presentation. I think it was an extremely interesting presentation. And what we will do now is to go to our panelists to begin with, and then we will take a couple of questions that I see in the chat box.
Okay.
You could also look at the questions yourself, or I could read them out after Mr. Ray has put his comments and his questions to you. Nilanjan?
Okay. Yeah. Good evening, and thank you, Ron, for the excellent presentation, flooded with different pictures. Some pictures are really frightening because of you started with failure of rocker bearings, how corrosion and accumulation of debris have started failing of rocker bearings. Then you have shown to us the failure of rubber bearings for high horizontal load and vertical load, and some failures occurred for the installation, or some rubber bearings have permanent set. Then you touched upon the various failures of pot bearing, especially the sealing ring failure, and combating with those failures and coming to a solution of these failures. In 1970s, as you said, the polyurethane pad, which is highly weather resistant and having a good properties, consistent properties rather, ranging from -70 to +120 degrees centigrade. You have introduced the disc bearing, which is also very easy to inspect. And you have also explained nicely the V-notch design, the advantage of it, and the higher compressive stress allowability, that's like 35 MPa. And you have then shared lots of projects. Just to name a few, is you have shown the intelligent use of the wax crayon for the YO Bridge project, and the wonderful arrangement of the diverging diamonds for the steel box girder bridge for Orlando, Florida, steel arch bridge, where you have used this bearing as lateral or horizontal bridge bearing. And also for the remote, the New Mexico bridge, you have used a temporary strut this bearing is also used in the temporary strut. And then come the magnificent Hoover Dam project, where you have shown how difficult the terrain and how beautiful the bridge is after completion with the disc bearing for the shorter columns. And you have shown also some typical problem of maintenance where the deck drainage is a part of perennial problem for a corrosion in the disc bearing project, where this problem can be easily solved if we regularly do the maintenance, periodic maintenance. And there are big bridges where the high capacity multidirectional load rotational bearing, where capacity is ranging from 25,000 kilonewton to 35,000 kilonewton, and one extra rose bridge bearing you have shown, which has a 45 kilonewton load with self weight of 21 ton. It's a quite amazing figure, 21 ton of self weight of a single bearing. With this size is 1.5 meter dia and 200 millimeter thickness, is also a remarkable achievement. And we have learned also there could be a scenario where the bridge is under water, flooded with water, having a bound force which causes uplift. And you have successfully designed various kinds of uplift disc bearings for the cable stayed bridge, light rail bridge, with especially wedge plate design, innovative design you have adopted. And the high rotation bearing with 8% rotation, you have introduced polyurethane pad in the pot bearing. And there's a funny design of a single point column design for the BMW car depot, with another interesting design we have shown for guiding flexibility guiding pad fitted with polyurethane. And there are various applications for the railway bridge you have wonderfully shown for metro rail, heavy rail class 1, and in AREMA specification, how the bearings are to be tested. You have described up to 30,000 kilonewton of vertical load, the bearings are performing well. And coming to serviceability, there are bearings which were installed 40 years ago, 30 years ago. In Hawaii, we have mentioned one project which is 40 years ago, and it was still is working properly. And you have tested the old samples with the new samples. You have tested with the cut piece from the old sample, and you compared the properties, which is comparable even after 40 years. Lastly, you have touched upon various projects for the isolation bearings. The bearings fitted with springs of polyurethane, which can have enormous flexibility, and to the designer of the building as well as bridges to have seismic isolation in all directions. And especially you have mentioned some good Indian projects like Sultanganj project. For the building, you have mentioned the Atmosphere building project in Kolkata. Last but not the least, the old Bandra Worli Setu or Rajiv Gandhi Setu you call now. You mentioned this is how the application of the disc bearings. At the end, you summarize that these are cost effective, easy for maintenance, a long-term reliable solution, not only for vertical and horizontal load, but also for isolation of structures against different high horizontal transient load like seismic, wind, etc. Now I want to share some of the questions which have appeared in the chat box. First question I would like to ask, it is, they are asking about the hardness of the disc and the material and about the service life.
Okay, that's a good question. It's It's a quite hard material. Urethanes tend to bridge the gap between high-strength plastics and rubbers, but it is a rubber material. It's and we measure the hardness on the D scale. It's about 62D. But again, people have asked us, how long will these last? And that's really the last thing you need to worry about. I mean, we've taken out discs that have been in service for over 30 years, and they look fine. There's really no problems with them at all. So I would guesstimate the service life would be on the 75 to 100-year lifespan. More concern, as I mentioned before, are the steel plates, keeping those protected from the corrosive elements.
Okay, thank you.
Mr. Roy, thank you for your comments. We will take the questions a little later.
Okay.
Let's just look at the comments of some of our esteemed executive committee members that we also have here.
Okay.
Let them also, let's allow them some time for interaction with Ron.
Yeah, sure.
Some questions. Also, we have a few members, like Engineer Gupta mentioned, we have a few members of the IRC committee. So I would like them also to interact with Ron so that we get some transfer of knowledge to our codes as well, in addition to all the information that Ron has given us. Let's also hear from Ron. If they have questions, then Ron can answer those questions. I think Engineer Goyal, if you could make your comments, please.
Thank you, Alok. Actually, I find that this is definitely a better alternative as compared to the normal elastomeric bearing that we are using. But it would be better if we can have a comparative comparison of the advantages and disadvantages of both the type of bearings and their preferable and the preferences where the different kinds of bearings can be used. Normally, elastomeric bearings, we are finding they are giving trouble even after 25 years, not even 25 years. But this disc bearing, as you have mentioned, they are giving good performance even after a period of about 45 or 48 years in many of the cases. So it's a good, I think it's a good option to use. Plus, the advantage is that it can give you the rotation in different directions, multi-directions. And you have got the added advantage, as you have shown, preloaded springs. All those things are a new concept altogether, which is not possible in simple elastomeric bearings. And then there is also a spherical bearing. Now, what are the relative advantages of using disc bearing over the spherical bearing? If all these comparisons are given somewhere, probably it will be very easy for the designers to choose the best kind of a bearing for a particular project. So otherwise, I find that this is a very meticulously prepared presentation, gives a lot of information. And the bearing is, of course, I am getting so much information about this type of bearing for the first time, actually. So it is very informative. Great work. Thank you very much.
Thank you, Goyal sir.
Thank you.
Thank you.
Harsha, Dr. Harshavardhan.
Yeah, thanks, Ron. Thanks for that wonderful presentation. I'm a Michigan guy myself, and I'm a Michigan, as is Atul. So we go back a long way, America and all that, studies and that. But I've seen the bearings on display at various IBS and FIB fora internationally. And I've always been wondering as to why it was difficult to introduce in India. You might remember we introduced it as consultants into the Whirlyband Relink. And in fact, it was the first use in India, along with the Osterberg cell, which was again introduced for the first time in India on that Whirlyband Relink. Somehow it's taken a long while to get into usable format in India. Is it because you feel that there is a bias towards the codal development? And if so, should the codal committee in India be, the IRC codal committee in India be seriously considering revising or creating a new code for this type of bearing? It obviously has a lot of flexibility. It obviously has an ease with which it can be combined for seismic isolation. It obviously has durability parameters which have been, as-built assessment after 30, 40 years. You have been able to assess some of those, the material, basically the material itself. These are all great advantages. Now, what would your advice be? Should we be seriously looking at a codal change? We don't have anything in terms of codal development in India, and maybe Nilanjan can also add to that. This is one question. The other is, of course, the performance characteristics, the material characteristics, the performance characteristics, the the V-notch that you have developed, whether that's a point of any likelihood of any weakness, the fatigue, the V-notch being a sort of a stress concentration point, would that over time have any displayed any fracture at that location or cracking at that location? Is it more prone, or is it a benefit? As you showed the bulging, the fact that it can bulge much better. Is that a benefit or a detriment in the long term? These are the things I would like to ask. And fantastic presentation. Thanks very much for those lovely looking bridges, apart from, of course, the bearing and the isolation device.
Yeah. Well, thank you. Those are good questions. I think, really, the disc bearing is something that we've, taken on, and our primary efforts in terms of marketing and promotion have been North America. We haven't really done a very good job outside of North America. So I think that's why you haven't seen a lot of usage of it in India and in Europe too. There hasn't been a real effort to promote outside in those areas as well too. I think regarding the material and the V-notch, you could do the disc with a flat surface on the edge like that, but the bulging would be excessive.
Yeah.
So part of that is visual. Part of it's visual. You don't want to necessarily see excessive bulging on the edge. The V-notch contains it. It kind of compresses into itself and keeps it from going too far. So it controls the amount of deflection that you get on the edge of that disc. In terms of long-term performance, these things have performed quite well, and they haven't really had any major issues. The only thing, as I mentioned, is plate corrosion. We've seen that happen on bearings, so that's probably common in many areas, especially if you're near the water, near the coast. Corrosion can be a problem. But we've come up with a lot of interesting coating techniques too. What's interesting in the USA is that there's 50 states. So it's like 50 different countries. They're all different. They all have different ideas what they like. So all different kind of coding systems. So there's lots of ideas in terms of that.
Right. Just one other question, one other comment. It's that this bearing, like any other bearing which uses metal, would obviously be prone to deck drainage, and you say very clearly that keep deck drainage away from bearings, a warning.
Right.
But that's common to any type of bearing, would it not? Which has metal, a part bearing or a disc bearing which has a metal surface. Sure. At any point, it's the same thing. The main issue is in the behavior of the material, the PU material, its characteristics over time, and that's what you've shown does not degrade so much. The properties are maintained over time.
Yeah, I think the key with the polyurethane is the loads we put on it are extremely conservative. We load it, as I mentioned, to before 35 megapascals, but the ultimate strength of that material is probably 20 times that. So you have a tremendous safety factor, and that's why after 30, 40 years, it still looks good, because we're really not pushing it. We're just putting a very conservative load on it.
All right. Thanks, Ross. Thanks very much.
Thank you, Harsha. I don't know if anybody else on our committee wants to raise a question. I don't see anybody raising their hands. I'm going to quickly see if there are any questions on the chat box. What type of material is you? Okay, you already answered that. Is there an Indian code for this kind of material? You already answered that. Harsha also asked that question. Since there is no code, somebody wants to know which standard in India is to be referred to while you design this. Is there like an AASHTO standard?
Yes. Yeah, there's AASHTO specifications. There's also, many state specifications too, because a lot of states write their own specs, But AASHTO is a good starting point. We have a generic spec we can show you, which covers a lot of the requirements. So there's certainly plenty of documentation to support the use of these devices.
Okay. Is there like a length of span that it can be used for? Is there a limitation there, or is there like a minimum span or a maximum span?
Not really. I think when you're talking about shorter span bridges, something like 30 meters, a rubber bearing probably be your best option, elastomeric bearing. But as the loads and the movements get bigger, then those bearings become troublesome. Most of the problems I've seen with rubber bearings have been on big ones. So you get to a point, usually it's around 1,000 kilonewtons, where you might want to consider looking at a disc type bearing.
Okay. All right. Somebody wants to know, is the polyurethane fully solid or does it have any metal reinforcing plates embedded within? So is it
Yeah, that's a good
reinforced
question.
polyurethane?
Yeah,
Or
it's
is it plain?
I'm sorry.
Is it plain polyurethane, which is fully solid, or does it have like a reinforcing element in it with metal plates inside?
Yeah, that's a good question too. No, it's solid polyurethane, so it's 100% elastomeric material.
Okay. Do you manufacture the polyurethane pads yourself?
We actually have a couple local sources that we go to for that polyurethane manufacturing companies, but they're made under our, supervision, and then we do tests on every batch. Every batch of polyurethane, we get test samples. So we run physical properties, tensile, elongation, and compression sets. So
Okay. How to structurally monitor during service? What is the life of a multi-rotational disc bearing? How much load can this bearing take?
how much load in terms of capacity? Well, we've actually made bearings up to let's see, I'm trying to convert in my head here real quickly, up to maybe like 60,000 kilonewtons. We've made them that big, there's really no limit. It's just it's a matter more of a practical limit. I mean, how big is your pier or your bearing seat? Can you fit this on there? Is really the issue there. So there's certainly no limit on that. What was the other part of that question? It was
a lot of questions. How to structurally monitor this during service?
Oh, right. Yeah. So we're not structural monitoring experts. So we've hooked up with that company. They're actually out of Colorado, BDI. And I know the guys at Metco have a project right now they're working with them very closely on. So again, you can monitor load, you can monitor movements, you can monitor rotations. Those things can all be incorporated into the bearing design. We just feel like there's people that are specialists in that area, and then we bring them on board.
Yeah. Are there any demerits for this type of bearing?
Well, I think that's a good question too. I think we're often compared to pot bearings and also spherical bearings. With the spherical bearing, there's a little less resistance to rotation, but a spherical bearing has issues with high horizontal forces. So that's one of the trade-offs on that. So that might be one area where disc bearings, they can be more expensive than a rubber bearing, elastomeric bearing, especially in the lower load ranges, so that's another issue that has to be dealt with. But for the most part, they've performed really well, and I've been involved with them for over 40 years, and I haven't, as I said, too, people complain about the pin, the central pin, because you can't see it during your inspections, but it's hermetically sealed in there. There's nothing that can get at it. You got a polyurethane pad with a 35 MPa load on it. No moisture or contaminants are going to get in there. So we haven't seen any problems with those pins.
Okay. What is the maximum damping that these bearings can provide when used as an isolation device?
Yeah, that's a good question too, because the neat thing about that we call it the Erratiquake or EQS bearing, but the neat thing about the EQS bearing is you can change the friction surfaces. Like if you use Teflon, you get a certain level of damping. If you use like a filled Teflon, you get a higher level of damping, or there's other materials that we use. We've even used bronze on some cases there. Bronze will give you even a higher level. So the damping level can be upwards of 50%, if you go to different types of sliding materials, or you can lower it, so it's a very user-friendly design.
There are a few questions on the properties of polyurethane. What's the Poisson's ratio and what's the shear modulus of polyurethane?
Yeah, now you're getting into areas where I have to go to my engineers to help me out with that. But certainly those types of that type of information is readily available. And if somebody wants to ask me directly, I think I posted I'll get my engineers involved. They'll answer some of those questions.
Okay, all right. What are the tests performed on this material?
So every batch of material, every batch of discs we get test samples. So we run, tensile, elongation. There's different tensile strengths measured at different compression set, different things like that. But then we do a representative sampling of the actual disc too. So we'll do load and rotation and all those types of tests as well too. So they're very thoroughly tested material.
Okay. Last but one question, is there any limitation on horizontal load on these bearings with respect to vertical loads? Because in some bearings, this is limited to 25%.
Right. There really isn't a limitation. It's kind of like the same thing with what's the maximum capacity. You basically size everything up for that load, you know. So we've done bearings where the horizontal load was higher than the vertical load. But you have obviously got a very big pin in the middle there. So it can be quite large, you know. It gets large quick when you start throwing. But especially those bearings we're supplying for California on that LAX airport project, the horizontal loads are huge, you know. So there isn't a limitation. It's just more of a practical thing.
Right. Last question, if you could share your views on why Europe is not adopting these bearings, because okay, not having manufacturers is one thing, but if there are inherent advantages to using such a bearing, why is it that it's not so popular in Europe?
Well, I think if nobody's promoting it, why would they adopt a code? You know, because there's no manufacturers in Europe that make disc bearings. If I were to go over there tomorrow and start promoting, I would think eventually we could get it approved, but nobody's pushing it, you know, so that's really the reason why. And that's primarily why, you know, in India you haven't had a lot, because we haven't really done a very good job of marketing there. But certainly since the Bandar Worli project, we've had a lot of inquiries, and then there's a lot of inquiries now. And that's a good case study. I mean, I'm trying to think how old those Bandar Worli bearings are. They've been in service now for many years.
20 years.
Is it 20? Yeah.
Yes. Almost,
Yeah.
Almost 20 years, yes.
Nearly 20 years.
Now, Mr. Bhove, just to say in this, for the Indian scenario, as a member of the IRC B6 committee, we are putting up the case for the preparation of the code for the disc bearings. And it was under preliminary discussion, it was discussed, and maybe next year we must have some codes for the disc bearing. It's our plan to have the codes.
So that's good information, because then we will be on the cutting edge. After the United States, we'll be the only country to have a code on these bearings. The IRC certainly is going places. It is great to hear that IRC will come out with its own codal implementation of the disc bearing. That's great. So that's about all the questions that we can take for the evening.
Just Atul, get
yes.
Professor S.K. Puri Saab's comments. He's the chair of the bearings committee.
I'm trying to get him, but I can't see him, nor I
Puri
can.
Saab, are you online? Can you?
I'm online.
Go ahead, sir.
I'm online. Can you hear me?
Yes,
sir.
Yes, we can hear you, sir. Please go on.
See, I would like to really acknowledge with great thanks the deliberations of today's presentation. Mr. Ronald has given a very, you see, like Mr. Niranjan Roy said, that last month in our meeting, we deliberated on this issue, that why we do not have a code on disc bearing, and we should have a code on disc bearing. But then what exactly came out was that by and large, we are, following Euro codes these days. Of course, we do follow ASTO also, and other codes also we prefer. But it was very surprising. That is why I raised this question for Mr. Ronaldo to, give a more comprehensive view of why is it so that the Europe is not adopting this, because that is not convincing. Even if in our committee we consider and discuss that since Europe doesn't have a manufacturer, therefore they are not. I think that would not cut the ice. I would request Mr. Ronald to kindly, if we can share with us some more reasons, because our problem in the committee would be that if we cannot promote any individual manufacturer. That is one of the basic reasons. So if it is said that RJ Watson is doing this thing, and they have successfully adopted these bearings in many projects. But still, if there are no other manufacturers, if it is not in the market, if the material being used is not commonly available, then it is very difficult to, make quotes for that. So with
Competition.
my comments, I know Mr. Vinay Gupta, Mr. Niranjan Ray, they are all, Mr. Bhaumik, they are all part of our committee. So I would like to have views of Mr. Ronald in this respect. Thank you very much.
Thank you, Puri Saab. Thank you very much for your comments. Ronald, you could probably respond to Mr. Puri directly at the conclusion. We're running out of time right now. So we will keep in touch with Mr. Puri, and then probably, anyway, Nilanjan is on the committee, Harsha is on the committee, Mr. Vinay Gupta is on the committee. So you already have a window to the committee yourself. But you could directly interact with Mr. Puri as well, so that you could answer his queries more convincingly than what you can on this platform, because we are running out of time.
I would want to add one thing, Mr. Atul. 1 second, if you give me 1 minute.
Yes, please go ahead.
Yeah, I think at least one European manufacturer has started manufacturing these bearings, not to a large scale, but they are manufacturing now. The thing is, answering Mr. Puri's question, they were not doing it earlier, but they have started manufacturing. They may not have so much experience as Mr. Watson's company, but it is not that there is no competition. At least one European manufacturer we know is manufacturing these bearings.
Okay, all right. Thank you, Dr. Mitra. With that, I think we come to an end of this session. I'm going to request the organizers. I think Ruhi will probably take over from me for the further movement of this program. Ruhi?
Sir, thank you, sir. So thank you for this session. I'll just like to quickly introduce our honorable secretaries who were unable to join this event today due to their commitments. So Ruhi, I'd just like you to request you to present the screen.
Yes.
So, Engineer Swapnil Joshi is an honorary secretary of IIB. He's an intellect who possesses bachelor's in civil engineering and double post-graduation from United Kingdom and NICMAR with specialization in construction project management along with law graduation. He has wide exposure in developing systems, has developed expertise in the field of CPM, combining technical and latest management tools such as Primavera, Asta, Power Project, Tylos, etc. He initiated and developed a mobile application Intendo project for daily monitoring and real-time data analysis of projects. With successful implementation of digitalized integrated approach and his expertise in project planning, BIM and advanced technologies, he is able to deliver the client's goal successfully. Swapnil has been rewarded by Indian Institution of Bridge Engineers from the hands of Shri Nitin Gadkari, Union Minister for Road Transport, Highways and Shipping in 2014. Next, Ruhi, I'd like you to present Gopal sir's presentation. So our next honorary secretary is Dr. Gopal Rai, who holds a PhD from IIT Bombay. His phenomenal level of prowess has enabled him to be associated with several prestigious projects, including the Apsara Reactor BARC, Mumbai Airport Bridge tendering of Mithi River, ESIC hospitals, JNPT ROB Bridge, and many more. He is Honorable Secretary of IIB, General Secretary of Association of Structural Rehabilitation and Retrofitting, Committee Member of SE Mumbai Center, BIS and ACI. He delivered 680 presentations nationwide and 27 presentations in international conferences. He is also a keynote speaker and author in 4 international conferences and more than 10 national conferences. Dr. Gopal Rai has a colossal research profile as well. More than 100 numbers of his research papers have been published in journals. Dr. Gopal Rai got the award for 50 Manufacturing Innovative Leaders at World Innovation Congress Award 2019. Also in Dubai for 40 most influential leaders under 40 year 2017 to 18 by Asia One and many more. So now with this, I would request Ruhi to please conclude the event with word of thanks. Thank you, Ruhi.
Thank you, Deepika. To all honorable dignitaries, it's my privilege to have been asked to propose a vote of thanks for our special lecture 13 series. I, on behalf of IIBE, extend a very hearty vote of thanks to all the members and non-members for gracing us with your presence and sharing with us your valuable feedback and suggestions. Firstly, I would like to thank our Director General, Engineer DG Dute sir, for always providing us with a vision for the future of IIBE. Our President, Engineer Vinay Gupta sir, for constantly guiding, motivating, and inspiring us to achieve the vision. I would like to thank our Treasurer, Mr. P.R. Kelkar sir, for being a strong supporter of IIBE. Our Honorary Secretary, Engineer Swapnil Joshi sir, for always managing this platform. Our Honorary Secretary, Dr. Gopal Rai sir, for always guiding us with his humorous side. I would also like to thank to our today's speaker, Mr. Ronald J. Watson, for his enlightening and entertaining presentation, and our panelist, Mr. Nilanjan Rai, for sharing his valuable opinion in this platform. I would like to thanks to our today's moderator, Engineer Atul Bobbe sir, for managing this webinar on this forum. I would also like to thanks to all executive committee members and panelists for their valuable presence and support. And Deepika, our coordinator of IIBE, for always helping us bringing the new ideas into reality and managing all the events of IIBE. Last but not the least, Mr. Hosaffa for all his IT support, and also to all the participants for always coming in huge number to make this webinar a success. Thank you.
Thank you very much, everybody.
Thank you, everyone.
Thank you.
Thank
Thank
you.
you.
Thanks, Ron.
Thank you,
Okay.
Ron.
Bye now. Take care.
Thanks, Ron. Thanks. Bye now.
Bye.
Goodbye, everybody.
Goodbye. Bye now.
Goodbye, sir.